Hopefully it's here now. It's still not here. What the hell? Dude, why does it take YouTube so long to get it in the live page? Alright, there we go, finally. It took so long. Alright. What's up, EXO? It seems like we're good. Yeah, I'll post a live link in the thing. Alright, looks like we're good. I'm gonna open up a paint tab too. Probably gonna need it. I'll probably make a custom role. I probably won't add everyone, but like I'll probably make a custom role. Like a live role or something. What's up, Jennifer? Welcome to the stream. Alright, I think everything is good. I need to remember what I left off on yesterday. Yeah, I think we were doing some of the recursive descent parsing here. So we should probably continue on with that. Let's see. So we implemented return, if, and while. We should probably do the rest of them. Variable declaration, block statement. We also have to implement Pratt parsing after. That's the fun part. I feel like this is going to be very fun doing Pratt parsing. Hopefully. And we should probably implement the helpers. Yeah, we probably should do that. I'll probably implement it in here. Let's just start with like, which one? Let's do check, I guess. We'll start with check. So check takes type. I'm just gonna copy the signature actually. Don't need the constant here. Or do we? So if we do like Parser check. Bool check took it to const. What did I do in earlier? Well, while you're doing your scripting, I will make some emojis for the server real quick. Alright, sounds good, EXO. You're pretty good at making Discord servers. You can help if you want. Yeah, I'll probably need some help with that. It's been a while since I've done that stuff, so I probably forgot everything. I'll probably let you know about that. What's going on? So, declaration is incompatible with parser check. declare line 43 of the parser.h, but it should be right. Right, it's a bool, check token type, const, why is that the case? Why does C++ do this, bro? It should be right? I mean, even with const, it said it's not. Okay, wait, I see. Okay. I forgot. Yeah. Okay, there we go. I thought it was giving me an error before I implemented, so I'm just up there. Okay, alright, for check, we are checking, I believe we're checking just the value of the token. I believe, where exactly do we use check so I can actually get a reference of exactly? Yeah, so we use it to check the current type, whether it's a semicolon here for the return statement. So, I guess the implementation would probably just be like, if we're, would we check if we're not at the end? I mean, I guess so, right? So, as long as we're not at the end, we'd probably just do something like return, or does it really matter? Because even if we're at the end, we'll probably just return our end of file token anyways. Well, okay, so we're checking the token type, so most cases we're not going to be checking for end of file token, right? So I guess as long as we're not at the end, we're returning, I guess we just peek to that value. So peek, and we want to grab the type of that value, the type that we put, or I did it wrong. Peek is the function that we're grabbing, peek.type, and we're returning if that's true with our current value that we're taking. But if it's not the case, then we just return false. I just think that's a good way of putting that. Yo, what's up, AJ Brady? What parsing method are you using? So let me show you. So for any type of statement that I have that's very top down, you can just go line by line. So like if statements, while statements, I'm doing recursive descent parsing. But for individual expressions that require precedence and stuff like that, we pass it on to the Pratt parser. So right now we have a little bit of the recursive descent parsing implemented for a couple statements, but we have yet to do any of the Pratt parsing yet. What's up, Swan? Okay, so that should be our check function. I should get these helper methods just banged out real quick. They shouldn't be too difficult. I guess we can do advance, set a token. I'm just gonna copy the signature. Well, it's pretty simple anyway. So token advance. Alright, so for advance, it would just be advancing by one token, essentially. So as long as we're not at the end, same as earlier, as long as we're not at the end, we want to return, I believe, our tokens, the list that we have, so we're going token by token. So tokens, and it should be very similar to the Lexer, just returning the index where current is. Tokens, current, and for not at the end, we want to increment it by 1. So okay, it should be that. Okay, it's very similar to the Lexer, except for the Lexer is the source string, the entire file, but this is going by token basis for the entire vector of tokens. This was going by characters, so yeah, tokens. Does C need look back? What do you mean by look back? We have a previous one. This is mainly for error, for when we implement error handling later. Do you think you'll test it this stream? Probably not. I probably have a lot to implement, which I might finish by tomorrow's stream. Depends though. We will see. I can't tell for sure if we'll finish it today. I can't tell for sure what the actual full implementation will look like. If we have a lot of trouble with the Pratt parser, then that might stall me a bit, but we'll see. Okay, so we want to return current plus plus, but if we're at the end, we don't want to return current plus plus. We just want to return the end of file token that we have, so that will just be token current. And I keep forgetting it's private member, so like that. That should be advanced. What's up, Ghost? How you doing, bro? The easy bit is everything but optimization. Yeah, I'm sure optimization is really hard. Okay, next. isAtEnd. We'll do isAtEnd. And doing pretty good, Ghost. Doing pretty good. Okay, so the end, I mean, I guess we're just checking for that end of file token, right? So we just want to check if that value, so if we're peeking to the next, just like earlier, if we're peeking to the next dot type, we can say if that token is token or token type, and say end of file token, essentially. And that should just be it. What else? Match. We can try match. Okay. So for match, match was more so is that implicit return in advance? Oh wait, my bad. Return, I forgot the return keyword. I appreciate that. Because we want to return the current value and then we want to increment it. Alright, so for match now. Yeah, so match, we more so used it over here and a couple other places, but here we're checking if the type matches so that we can call the function here. The reason why we made it a initializer list is because of this. We can have multiple values that we might want here. So I guess we just need to iterate through each type, maybe? So like, maybe like a for loop or something, going through each token in the list and checking if that matches what we need. So probably like a for loop. Let's do that. Let's try. So maybe like for the token type that we have, we can say types. We can just go through this entire list, and if that type matches, right? So we're gonna be using the check, probably the check keyword, or will we use peak? Probably not peak. Peak's for the next value, so probably checks the current one. We still have yet to implement it, but yeah, check should check the current one if I implement it right. So if our check, and I believe check takes the token type that we're taking. Yeah, token type. So check, we'll say, I guess the type that we're iterating through. Type. I guess we just advance forward, right? If this matches, we just keep going forward. So returning that token and advancing forward. And then return true. And outside of the for loop, return false. I have a question. How do you get the body and args like for functions? How I plan to implement that is, let me go to my abstract syntax tree. I believe it was a vector for arguments, and I don't know if that's valid or accurate, but where's the arguments for a function call, because they can pass in any amount of arguments. We're not able to tell the amount, so it's just going to be a vector of a bunch of arguments there that they pass in. That may or may not be a good way of doing it, but we'll see. Is it mainly because it's const and also purely a view and of course temporary access? Which function are you talking about? Okay, where was I? Yeah, match. I think we have a couple more. I'm really eager to get to the Pratt parsing parts. I kind of want to wrap this up, but we gotta go in order. Okay, consume. Consume's mainly just for checking if the type's correct and then printing out an error message if it's not. So, yeah, let me grab that. Right, how do we do consume? I guess we're just, I mean, it's essentially the same. the same as match, right? Just checking the type and moving forward, just that this is more so used if we actually need a value to actually be accurate there for error handling later. So I think it's just very similar. And we're just gonna return that token, right? So I guess we can just call that function advance. Advance can handle that part. How do I handle the messaging though? Exo students, you should try Rust. You think you might be interested in Rust though? Okay, but how do I handle errors? I mean, I guess just it's there. Print out the message, not the code, like the message. Maybe I think I'll check that later. Or we can probably check that now, to be honest. For what is the best way to handle the error message there? Alright, let him do that and we can go forward. So consume is done, and we need peak 2. Okay, 2 more left and we can finish off the recursive descent. He doesn't go for Roblox, so he could. Yeah, but if he's only interested in Roblox, I guess he wouldn't really do Rust, right? I don't think Roblox has that support. I think Rust is way too complicated for your average Lua coder. It's been pretty good, Swan. Been a pretty good day. Alright, peak. Peak is just the next one, right? Let me check for sure. Peak, yeah, peak just looks at the current without advancing. Okay. I think the thing is, like most Roblox devs, I guess, unless you're really passionate about making a game, I guess most of them just make slop of brain rot content, so they're not really gonna want to learn a language like Rust. They're probably just gonna vibe code Lua or something. I don't know. That's just how I see it. Unless you're like a really big developer who's making games like that. Okay, peak. I guess just as long as we're not at the end. Or does it really matter? Does it matter here? I mean, I guess it does. But it's just the current value, right? So it doesn't really matter if it's the end. We're not going past the end. For these ones, advanced, we have the ability to go past the end, which is not possible. Which is why we needed an isAtEnd check. But I don't think really needed for this case. I might be wrong though. But yeah, I guess we can just return it. How did I do that in the lecture? I guess... Well, I did do the end thing. But that's more so for chars. Wait, why did I do it? Why did I do this? Why did I do this? Wait, I'm really confused on why I did that. That's only for null terminated strings, but... Or did I just like... I don't know why I did that. Probably because your advance will have off by 1 increment. Yeah, so for advance, right? Let me go back up here. Advance, we're consuming the current token that we're on, but we want to advance the token for the next token. So like this would essentially just be doing, let me type it out. It's a post increment, so it'd essentially just be doing like temp, setting that current, incrementing current, and then returning temp back to me to consume the token that we're on. And this could be a problem for the end of the file, because if we're already at the end of the file, we don't want to consume an extra token. That's why we needed that check there. But for peak, we don't necessarily need that though, right? Because we're just checking that current token before we consume it to check if it's valid or not. Yeah, it should be the current token that it's on. Well, the tokens here, right? The tokens is the vector of all the tokens that are passed through, and the current value is wherever our current is being positioned to whichever token. That's why I initialize them as so up here. This the token should be passed in by the lexer, which I haven't implemented that part yet, but that's what it should be doing. Okay, yeah, I'm just gonna, let's not overthink it. We always have Claude with us to check any missed logic or anything. So let's just do return tokens of current value. I keep forgetting. There we go. Alright, one more I think. Previous, and that's for error handling later. So let me grab that. I mean, how do you add the current token to the vector tokens for tokens? I'm assuming later when we actually implement that, we'll probably take it from the lexer that goes through all the tokens, and then we add them to the vector as we go through. That's what I assumed though. So previous is just gonna be return. I mean, it's literally just gonna be return the previous token. So tokens current -1. That should literally just be that. Alright, all helper functions are done. I'm probably doing a very bad practice right now. I'm writing the whole parser without testing it even once, which might be a bad thing, but I don't know how to test it though. How do I test it before it's even done? I guess I'd probably have to set up the main function or something, but I don't know. I probably have to set up the run function to actually run it. Yeah, I tested the lecture already. The lecture works perfectly for my subset of C, for the tokens that we have listed. The lecture worked after a little bit of debugging. Like, I wrote the lecture, I had to do a couple of debugging, which maybe it was like 15 minutes of it. It wasn't really that bad. I think the logic I wrote was pretty good for the first time. I just missed a couple things, so I had to rewrite some parts. But yeah. Yeah, 16 viewers. I don't know, lately it's been like chilling at like 7 to 20, like any amount from then at all times in the stream, which is really surprising to me. But I appreciate it though. I appreciate it that we're getting that much support. Where was I? So we just finished the helper functions, right? Yeah. Yeah, all helper functions done. We need to finish the rest. Just 2 more functions within the recursive descent parsing. So, yeah, let's do that. Let's see if I can refresh myself on the recursive descent parsing. So, let me grab that. Yeah, absolutely, Swan. I'm growing. When I was writing the emulator, it was like I was always at 1, 2, maybe 3 viewers at most. But now we're like going pretty good, so I definitely appreciate it a lot. Okay, so let me grab the variable declaration. Statement parser var declaration. Okay, so a variable declaration will just be something like an int x. You checked out the emulator? Yo, I appreciate that. Seems pretty good. Thank you, thank you. I did test it beforehand. I tested most cases for the emulator. There might be some edge cases I didn't test. But I guess we'll find out as we make the backend for the compiler to connect the two together. I'm not gonna lie, pipelining was a very tedious process for the emulator. Instruction pipelining was actually... I don't even know. Do I hate pipelining more than I hate the visitor pattern? I don't know. I don't really know, but they're both up there in things that were difficult for me. Okay, so int, a variable declaration would be like int x. We know that we are jumping to the variable declaration function if we have our match, if we match any of these keywords, int, float, void, char, and I'll probably add more keywords later, but for now we have these for the data types. So that's covered. We need to cover the identifier name, equal sign, and then whatever literal value they put. So let's say 34 or something. Okay. So let me look at the syntax tree. Yeah, variable declaration, so the name and the initializer. Okay. Alright, let's actually do that. So what's your standard go-to compiler? Clang your GCC? I mean, I guess it's just GCC. I need to look into that more on what to actually use, like for specifics. But I just have GCC enabled. Okay, so I guess we're just consuming our identifier. We can call that like token name, just how we had it in the here, and we can call that like consume. I've got you into coding more. Hey, that's amazing, man. That's amazing. Guess how long it takes to tokenize 50 lines of doc? How long? 1.5 seconds. I should have checked the time for mine. I didn't check the time, I just like checked the output. Okay, consuming tokens, so we're going to be consuming the token type of the identifier. Right, the identifier, right? That's the, yeah, that's the identifier. I mixed it up for a second. Yeah, so I don't know if it's slow or not. That's up to the senior coders to tell us that if that's slow or not. Who actually build compilers and stuff. I think that's probably a long time though, right? Maybe? Like, it should probably be in like milliseconds, probably. I'm not sure though. Probably even microseconds. No, probably milliseconds or something. I'm not really sure though. Okay, so our expect. So expected. I guess we could just say real name. Oh, you're just kidding. Makes sense. Okay, yes, that looks good. For the name, then we want to consume a token for the equal sign. Or, let me look back for a second. So on some of my old ones here. I mean, I guess it's possible to say int x that. So in that case, it's not always guaranteed that we'll have a equal sign, right? So we don't want to consume it because it's not always guaranteed. So maybe it's very similar to like our else case. Our value can be a null pointer. Brother got me going optimization mode. For one line, I just said 0.0. Yo, 22 people watching, that's crazy. That's crazy. Okay, I'm gonna look back here, so I guess just like making a unique pointer, right? So set unique pointer, and what would it be? Just the expression, I guess? It'd probably be an expression type, because this is considered like an expression, so and we can call that initializer. It should reflect my, yeah, it's initializer, yeah, it should reflect that perfectly. And this could possibly be a null pointer, depending on if they decide to or not. And if that's the case, we want to check if I believe I use match, right? For the, yeah, we want to use the same exact thing here. So we want to say if match token type equal sign, so I guess equal and I guess just setting initializer to parse expert, just like how we usually do. Shouldn't you get the type first? Isn't that what the type checker is for though? Like after later on getting the type checker to actually validate the types. For now we're just checking if the syntax is valid. Oh, you mean like get the type? We already have that up here. So the statement function, the overarching statement function that handles all our other functions like variable declaration, read statement, if it matches the keyword to get into that. So if we have an int, float, void, or char, then it will call variable declaration. But if it doesn't hit any of these, it won't do that in the first place. I don't know if that's the best way I thought of doing it. I'm not sure if that's the best way of doing it, but maybe that's... It works, so I'm just gonna go with it for now. Whose language do you think would be faster? His or mine? Probably yours, to be honest. Because I'm trying to implement a custom backend, so yours is gonna be faster because you're using LLVM. Mine's gonna be significantly slower at first because I have to do all like optimizations by myself. I feel like eventually I might probably get tired of the optimizations or something, so I might use LLVM. Where were we? So we just finished the parse expression, so we need a semicolon. That's without a doubt. We can't have no semicolon. So we do need to consume the token, and we want to say consume token type semicolon. Yo, what's up, SS Low? And not necessarily that you're lazy. Maybe it's just that I'm dumb for implementing a custom backend because I have to do optimizations. Who knows? Maybe I'll get too frustrated with that and probably do LLVM. Because risc-v does have LLVM support, so I should be able to do LLVM as a fallback if I need to. Transpiler is crazy. That's a crazy name. Expected semicolon after, I guess just initializer. Yeah. And then we want to do return. Return did make unique, and this is gonna be for the var. I can't type right now, but it's fine. This is for the variable declaration statement type. And we are going to be returning two values, which should be the name and the initializer. So name should just, name is not a unique pointer, so I guess just return the name, right? we don't need to call student move on it. So return name, or not return, sorry. We just want to say name, and then call student move on the initializer, which is a new pointer. The semicolon should be here. I believe that's good. Yeah, I think that's good for this function. We have one more function for our recursive descent parsing before we move on to Pratt parsing, which will be interesting. Very interesting. So let's do the block statement now. Let's bang this out real quick. So unique pointer, block statement. Alright, so for block statement, it's just gonna be whatever's inside a block. So literally any amount of whatever they have in here. It should be, I believe, a vector. I set a vector for that. Wait, so interpreter and compiled. Isn't that what they call, what is that compiler called? Like just-in-time compiler? Isn't that like a mix of interpreter and compiler? Is that what you're doing, Ghost, or is it something completely different, like a different paradigm? Let me check. For the block statement, yes, for the block statement we have our... We're gonna remake the parser. Wait, did you even make the parser yet? I thought you just finished Elixir. Alright, that's crazy. I do have Linux. I do have Linux, guys. Just, I haven't switched over on my main PC yet. Okay, for the block statement, yeah, we have a vector of a bunch of statements, because a body can have any amount of statements that we have. So we're probably gonna want, it's just gonna pass in this one, so we'll probably say, I'm just gonna do an example here. So statement. So it's gonna be something like this, just any amount of statements they add. So, is a block statement allowed to be empty? I guess not, so let me grab that over. Let me grab this over. I'm gonna call it like statements instead. Okay, so we'll set that. I guess we just keep going as we don't hit the end of the block, but okay, so to hit the end of a block, we need to hit the right brace. Do I have the block statement here? So if we have a left brace, we return the block statement, so we enter the function. Then we set our vector of statements. And as long as you do believe it can be, a block statement can be empty. So I guess, do we have a null pointer there? How does that work? Wait, can we have like a vector of a bunch of null pointers? Or like, I guess it'd just be one null pointer because they haven't wrote anything, but how does that work? Yeah, it's a scope, so it doesn't need anything. Okay, let's... So can we say, so how do we initialize, say that null pointer, no, right? So we can't do that. How would we, since this is a vector, it's not an individual unique pointer, so how do we set null pointer for this? On Linux, the computer does not auto-update, but Windows does. Yeah, you're right, dude. Sometimes Windows just be like restarting by itself to update. If I haven't done an update in a while, like I've been neglecting it, it just restarts automatically and does the update. And it's such like a pain point there. He's a stood monostate. Oh, yeah. Oh, yeah. Stood monostates for the null values, right? So I need to read about stood monostate again. Give me a second. Like, does it need any specifics? Can I just write like, this is where my C++ language knowledge is kind of messing me up here, but so we can just write like stood monostate. But do we need what do we need to pass in? Like, do we just can't say I'm getting this part right now. I mean, we can come back to that. I'll come back to that in a second. I just want to map out the rest of it though. This can be an infinite amount of statements, so we probably want to do a while check. So while not, I guess checking. So check if our token type, if our current token type has hit right brace. And also, I guess, not at the end, right? Then I guess we just add that value to the block. So statements dot pushback, and we'll take our specific what is it? The specific statements, I guess. Well, no, it's not the full statement. So what exactly are we taking? I guess you're my favorite streamer. Yo, I appreciate you, Ghost. That's a very kind thing to say. Alright, this block statement function is kind of destroying me here. It's got me in a headlock right here, so okay, so the only way we can pass in that stood monostate is we use that stood variance. So, okay, so essentially, I guess what you're saying is that it can either be a vector of values or it could be just null. Let me include a variant up here. I cannot type. Alright, so include variant. And so you're saying passing monostate as one value, and then the vector, I guess, of these statements, but it'll just be like this. So I guess it's like this, and then we say statements like that. Oh, you could. Why is variance instead of check if vector is empty? That's also a good way of doing it, I guess. Wait, does empty check if it's empty, or does it, like, empty the vector? I thought it checks if it's empty or not. Yeah, because the empty should just check, right, if it's empty or not, so he does bring up a good point. This might be a bit of an overcomplication. Yeah, it just returns a bool if it's true or not. So, okay, let me get that. So this is fine, right? This is fine to keep as it is, but we do a later check if it's empty or not. Where would we do the check? You're good, Swan, don't worry, you're good. I always love to hear different ideas. Okay, I guess in here, before our pushback, I'll just rewrite that. Okay, so in here, if our statement dot is it empty, we just call that. If statement's not empty, so just to return either true or false. Well, okay, if it's not empty, if it's not empty, we want to push back something. So we'll do statements dot pushback. You have an idea, Ghost? What's your idea? So we'll probably do like pushback. We're pushing back each statement, so the individual statement itself should be handled by this function. So should we recall the statement function to see what it falls under? I guess. I think that would work. We're making Rust. That's crazy. But that would mean I have to learn Rust for like a month or two, maybe even 3 months, and then I have to restart. You gotta go for a bit, or I'll see you later, Swan. See you later. I appreciate you for being here. Alright, I think this should work. In theory, it works. Yeah. Okay, we'll check later. I mean, you're already making your language in Rust, Ghost, so I mean, you gotta focus on your own language. Okay, so the block statement, let me just run through this again. So we will get to the Pratt parser like after this, so Alright, so if it hits the left brace, block statement. If once we're in the block statement, we get the vector of our statement. We're checking as long as we don't have the right brace. We don't hit the right brace to close it, and as long as we're at the end of the file, then we do a further check. If statement's not empty, then we can push back our statements. Whatever statements we have in there, which will be checked by our further functions, whatever they have in the block. So they could have like another if statement or a while or return, anything. How does the check work? What check? Oh, like the check function? It should just check the current token that it's on. So if the current token we're at is a right brace, we don't enter the function again. Or we exit the while loop, sorry. I'll show you. It should be up here. Where is it? Check. Yeah, right up here. As long as we're not at the end of the file, we return just a type. We're just checking the type, that's it. The current type that we're on, the current value, the current token. And it'll return true or not depending on what you pass in. So that's what we have here. So we're checking if right brace, which is this right brace here, to close off the block statement. Yeah. So we can say that's kind of done. So yeah, so we'll just exit out after that's done. And I believe we can just consume the tokens that we got. So probably consume token, consume the next token. I mean, sorry, the semi. Would it be a semicolon? No, we're consuming the right brace. We're consuming the right brace because we need this to end the block. No semicolons needed. So we do need the consume, but not for semicolon. We do need it for a right brace though. So right brace, and we'll say like expected. Right brace would be this expected right brace after statements. And yeah, that should work. Then do our normal return as usual. I think the statements.empty check is redundant as you stack initializer, correct? The statements, not statements empty condition never be true. Okay, I see your point. I do see your point there, because we haven't pushed back anything, so it's obviously gonna be empty. So it's never gonna actually come in here. Wait, I overthought that. Wait. Yeah, it wouldn't. Yeah. So wait. Okay, I messed that up big time. So we have statements of pushback. Yeah, this check probably shouldn't be here, right? It shouldn't be here. But I'm not exactly sure where it should be, if I'm being honest. Because we need our statements to be pushed back here onto the vector. But in the case of there being no statements at all, would this throw an error here in those cases? And if so, how do we actually mitigate that, prevent that from happening? Welcome back, AJ Brady. Yeah, I think Slow comes in every once in a while. I think he was here yesterday, I think. I might be severely overthinking this, but maybe I'll check with AI or something about it. Check the statement itself. So this statement itself, right? When we call it, it's gonna go to the dispatch function. And if there's no statement at all, it's just gonna pass through all of these. But that's gonna be a problem. It's gonna hit the expression statement here, which I have to do after for any regular expressions that are there. Let me just write out this part first, and then I'll probably give it to Claude, and then see. So this is for the block statement. And it's only one parameter, which should be to move on the vector. So statement, that vector that we initialized, so yeah. How long have you been on YouTube for? Just like a couple months. Originally when I started this back in December, I think, maybe November, October, something like that. It was gonna be for Roblox scripting, but I scratched that. And around March I started the emulator project, and that's where the C++ started. Around April-ish, March, something like that. Sort of when I started coding in December. Yeah, but the channel was completely different back then. I uploaded like a couple of Roblox scripting videos. They're all unlisted now, but yeah. Let me go to this function here. So this one is just for regular, any expression. Because any random expression we have, for every other one we have like a keyword like while or if or return to actually dispatch from this function. But in the case of a regular, any random expression that we have, there's no case to get it in there, so we just need to put it in this statement. So we'd probably say just the expression itself. We're passing the expression that we have. Let me do a little comment here. So it's the expression itself. Passing that off to the Pratt parser to do its work. Semicolon. We need to check if it's semicolon. So token type of. Oh, sorry, I wrote it wrong. Token type of semicolon, and that expected semicolon after expression. And then return, as we usually do, return make unique, and that will be for the express statement. And that should just be one parameter, just the unique pointer for the expression itself. So what year is this? No AI assistant? Yo, what's up, Hamid? I am, but in just very certain cases. Because I'm currently learning right now, I don't see a point in using it too much if I'm just learning. Maybe later, once I actually know everything about compilers, then I can probably just use AI and debug that code. But for any AI usage I use, it's just like very certain cases if I don't really understand, if I'm stuck in it for like 10, 15, 20 minutes. Guess the age of EXO. I mean, didn't he say he was like 15 or something? He said he was in high school. Yeah, also for architecture decisions, like, because I don't know how, like, compilers are exactly architected all the way down, because it's the first time, so if I don't understand it, then I just need to understand how compilers are actually implemented by the standard. He's old? What do you mean, Ghost? What do you mean by that? Okay, let's go back. Yeah, in this case, I am either overthinking it or just wrong. So I want to check this. The block statement. So for the blocks statement, there is a possibility that there are no statements. Yeah, probably don't share EXO's personal information or something. Good looking out, Swan. Good looking out. Yo, 26 people in the chat. 26 people in the stream, that's amazing. Feel free to join the Discord in the description. It's in the description of the stream. Alright, let me get this. So, there's a possibility that there are no statements. Can't do a statement check. I'm not sure about. Let me also give him the statements function so he has a little bit of the statement function so he knows what is going on when we call statement. Let's see. Oh, he's probably gonna give me code, but it's already correct as written. The while loop condition handles the empty block case naturally, does it? Oh, dude, I was really just overthinking it, because if like we're not counting white space, it's automatically gonna hit the brace. So it's never gonna even go into this while loop if it's empty. Okay, I was like, okay, I was really overthinking that. Well, I guess you live and you learn, I guess. All right, so I think we're done there. When do you usually end stream? It depends. Maybe like sometime 12:30ish. I mean, we're having really good streams lately, so I kind of don't want to end it like fast, so we'll see. I think we're all done. It's time to move on to the Pratt parser, I think. We can get rid of that. I already resolved that. We don't have a parsing struct. Well, I'm making a function for parsing later, which I have to implement later. For in general parsing. Yeah, don't worry, I'll get my sleep. Don't worry. Don't worry, AJ. Alright. One time you found a bug fix in a dream? Dude, that's crazy. That's actually crazy. The project that you were working on got in your head so much that it came in your dream and gave you the solution. Hey, that's the power of the subconscious mind right there. Okay, so this might be interesting. Parsing. I have not been thinking about my tests. Not yet, at least. I might do that tomorrow. I might just map out some tests to have. That's called bootstrapping? Like remaking a... That's crazy. That's crazy. That's for a future time. This language probably won't be done for a while. So that's a future thing. Alright, let me stop stalling and get to the Pratt parser. I don't know, maybe I'm excited and also scared to go through the Pratt parser, but let's see. Let me just kind of like rethink of the Pratt parser. So yeah, so we have like an expression like 1, 2 times 3, right? So we have different functions for that null denotation, which only occurs if there's nothing to the left of it or if it's like a literal value. And then the left denotation, which takes the left node of the operator and gets the right node later on. Let me try and map it out. Let me think about it. It might take me a while to get off my feet here. So we're starting with 1 right here. And this will be a literal node value that we have. So in our AST, we have the literal node value. Literal node, so that should cover that. And we'll basically call nud on that function, nud for that. Then we move towards the plus. Let's say this has like a binding power of, oh my god, the drawing is so bad. But let's say it has a binding power of, I don't know, 20. I need to map out the binding power table after. Right. Then it looks towards 2. But it does not consume it because the immediate token after that, the binding power of this would be higher. Binding power would be 30 or something, I don't know. I don't know the values yet, but something like that. So this would be grouped together. And this would eventually be the right node of that, of the plus. So the plus's right node would end up being 6, and then the left node, it already has that, which would be 1. So something like that, I believe. Rust was originally written in OCaml, then was bootstrapped from there. Hey, what's up, Lego Edits? Very enthusiastic there. Very enthusiastic entrance. What's up, man? Yep, it's C++. Alright, what are some other things we need to think of? So, we need to also have associativity. I mean, realistically, it doesn't matter. It doesn't matter if it's like this, because it can do it in any way. It could do this first, or it could do this first. But to make our program efficient, like not efficient, but just run the same time every time, to make sure it always gets the left first, we do need to handle associativity as well. And most things are left associativity, from left to right. But for assignment, like x equals 4, that's from right to left. So if you have like x equals y equals 3, it does the y first and then passes that to the x. That seems like a hassle, but we'll probably do that. I mean, let's just start with the simple parse expression, probably. Or let's set up the binding power first. I kind of want to do that first. Let's set up binding power. I guess we can just set it up here. Isn't it? Isn't it a lot? I thought you can do like... I'm pretty sure I thought you could do like this and have it like that, I believe, right? Or something along those lines, right? Or do we... I mean, I guess it's my language, right? I guess I don't have to do that, but... I guess I don't have to have that. But I'm pretty sure that's right in terms of language. I know when I was like researching about it, that was something that came up on my radar. Please do not do that. I mean, I guess we can omit it. I don't really mind. If that makes it easier, I guess. I mean, realistically, what are the cases where you would actually need to do double assignment? Are there any like very important cases where you'd need to do double assignment? Like that? Not really, right? So we can make that like illegal in our language. But still, even so, it's still right to left associativity though. Even if we don't have the nesting part. It's still gonna take the 4 and put that into x. So it's still gonna be right to left. It could introduce weird bugs if I have that in. Yeah, probably. Probably, to be honest. Assignment is not an expression. Is it not? I mean, it does like use the same thing that any normal expression would do. It has associativity, it has precedence, and it ends with a semicolon like any other expression. That's why I included it in here. So we could omit it. It'd be under binary, because it'd be under a binary. Yeah, functionally, yeah, that makes sense. I mean, let's not overthink that too much. We'll get to that when it gets there, I guess. I want to build the binding power table though. Let me get the binding power thing here. Alright, we need to think about how to actually do this. We need to set up like a list. Let me just get rid of all this. Alright, it can be like that. So we need to see what is actually in precedence, which I don't remember off the top of my head, so I'm gonna go to risc-v. I believe it should be here. Depending on what our different tokens we have so far are. So we do have comparison operators, quality operator, we have addition, subtraction, I mean pretty much all those. We don't have like increment or decrement though or anything like that yet for our basic. I mean, increment's probably just something we implement later for the backend stuff or whatever is there. Okay. Let me just look through this and kind of map it out. Okay, we are gonna have unary though. We are gonna have unary. Parentheses as well. We do have parentheses. So parentheses is gonna be the top of the. Parentheses is gonna be the top of the batch. It will have the highest binding power. I'm not gonna assign the value yet. We don't know how many values are under, so. I know like people say use Windows just for certain games, I guess. I know for Valorant, the Riot Vanguard doesn't work on Linux. I heard that complaint a lot, so maybe that's a thing. Anti-cheats, yeah. That's one of the biggest problems there. But even so, most people aren't going to switch to Linux. Most people don't care to switch to Linux. Like most regular people. And most computers come pre-installed with Windows anyway, so they're never going to really care to change that. But yeah, for devs, I guess, yeah. It's mainly for devs. Yo, what's up, EXO? You're back? Welcome back, EXO. Alright, let's continue. So parentheses is that, and we have any other ones in here that we have? No, not really. Not as of now. Unary plus and minus. Well, unary plus, I guess we don't really need unary plus because it's kind of like implicit when you write a regular number, so I guess I'll call it like un minus. And we'll set that like a binding power or something later. I don't know. And there's also unary not that we have in ours. Let's just map this out real quick. So unary minus, unary not. Nothing else there. Additions, multiplications, divisions, the next batch. Okay, that sucks, but that's okay. That's the next batch, moving a precedence down. Plus minus is another precedence down. We don't have bitwise shifts, we don't have bitwise operations. Comparison, any comparison, I'll just call it comp. That's not it, but okay. Right, comp, and that should be another one down. We don't have bitwise. Oh, I actually didn't know that equality was... Oh, equality is one step down too, okay. You know what, bro, so chill. I never hear bro raise his voice or anything. I don't have a need to. Who knows in the future if C++ really pisses me off, but I don't have a need to right now. I'm just chilling. Yeah, okay, now we have our binding power, so I'll probably just assign it as we go. So we'll probably say this, we'll go in increments by 10 or something. 10, I'm just gonna type it to be honest. So 10, 20 for this, I can say that's 30, say that's 40, 50, and then we can say the top one is 60 or something. I don't think it should interfere if they're a good decent bit apart. If C++ pisses you off, reduce Rust. Man, I feel like Ghost finds a way to sneak Rust into any conversation. Just wait till you get into the dark arts of metaprogramming. Not looking forward to that. Okay, I guess we could do like a switch case statement here to set our binding powers, because multiple types have the same binding power, so we can just set a switch case statement and fall through whenever we need to. You're remaking NeoVim in Rust? Dang. You're gonna remake everything in Rust at this point. Remake Windows in Rust. Alright, yeah, let's start. So probably a switch case statement, as I said, so we're gonna need to do switch of the token. Token, the type of it, I guess. Token.type should return. Yeah, token.type will return whatever keyword it is, so yeah, so if we're checking the token.type. Oh, where am I? We have the same idea, remake Windows in Rust. Hey, that's nice, that's nice. Remake the world in Rust. For NeoVim, I use TreeSitter and LSP0, then I make plugins. Okay, why am I'm blanking here. I'm blanking. Oh yeah, case, sorry. Case of, yeah, we just have to return type, so token type, right, token type. Let's start with the top precedent, so we'll say token type. Or should we go bottom up? Let's go bottom up. So let's say equality. So equal. Well, no, equal is just assignment. Oh yeah, assignment. Wait, what is assignment in? Okay, assignment is the lowest of the low. Okay, that kind of puts my increment by 10 to shit, but I guess we'll say assignment will probably be, I'll say 5. So for equality, for that case, we want it to, it's just going to be a return by itself. You can just say return on the same line. And return 5. Doesn't previous need an optional, given at the start current is 0? Let me see. But are we gonna hit any errors at the start though? I feel like it will at least be consuming a couple tokens before we reach that part. I mean, like, let's say someone immediately starts writing like int equals 3 or something. It's invalid at this point. So it's not necessarily the start. We'll still have something in there. Right? I don't know if I'm thinking of it wrong. Once we get to error handling, I guess I'll see. Is there a way to start off anything with just something wrong? I don't really know, but we'll be consuming that token anyway, so we'll be able to return previous. Binding power. Okay, so 5 for that. We'll probably write tags for each one. So I'll say assignment. Let's say case token type. What's next? Equality. Which will be equal to equal. And we can do a small little fall through. And we can say exclamation equal. And that should be it for assignment, or not assignment, equality. Return 10. Case. Okay, next is going to be comparison, which is a lot of them, so I'll probably just low-key like do this and change them. How many are there? So there's less than or equal to. There's greater than or equal to. Just greater than in general. Just less in general. Use end curses for error handling? What is that? What is end curses? That might be a dumb question, but I don't know. I just haven't heard of that yet, so feel free to enlighten me about that. Token type. Any more? I'm gonna check the page. There's 4 of them, so we covered them all. So you want to say return 20. 20, next is plus and minus. It should go pretty fast from here. Plus. Minus. And we say return 30. I think it's called star, right? Star and slash. If after stream, can you and everyone else in Discord watch the movie I'll stream it on YouTube? Hey, maybe. Maybe I might just go to sleep though after. It's probably gonna be late after I finish the stream. What's up, Junior? If you have an unstable parser, it might be. Oh, you're not writing in C, are you? No, I'm writing in C++. My first time writing a compiler, so yeah. You start from the GNU compiler? Maybe. What's up, Lucy? Alright, slash. Unary minus, I believe it's unary minus, and also not, unary not and unary minus, so. Wait. It's going pretty good, Build the syntax? Yeah, I built the syntax. That was part for the lecture. Well, we're building the syntax right now. I built the tokens and now we're building the syntax right now. I did the syntax for the statements, like if statements, variable declaration, while statements, if statements. That's for recursive design parsing, since we don't need any precedence rules or anything like that, so. And currently it's the Pratt parser. Okay, wait, how do I handle this though? How will it know it's unary minus? Since we already have a minus here, how will it know it's unary minus? I'm not really sure about unary minus, to be honest. But we do have one for the exclamation to cover that. And the last two, it would just be if it's a parentheses, if we hit that first parentheses. I need to change this. Unary. Okay, everything's still good with the stream. Okay. Okay, unary is gonna be, or not unary, that parentheses. Not brace. Parentheses. And that will be precedence in 60. To be honest, I don't know what he's talking about. Maybe I'm just not that far yet to understand what he's talking about. I mean, you have to take into account this is the first time writing something like this, so I'm not gonna do like very confusing stuff like OOP or whatever other paradigm is there, and all memory management and stuff. That will be like later. Or else I'll probably just be like way too bombarded with a lot of stuff. For those LARPing programming languages, I feel like he is, not gonna lie. Yeah, C is a fine language. Okay, I don't know if we actually need the precedence value here for the unary minus, because we'll probably be implementing the implementation for that later, but I just don't know how it distinguish though. I guess we'll figure that out when we get to it though. And this should be yeah, it's very much situational. Depends. It's 12 a.m. How long have we been streaming for? Probably like 2 hours maybe? Could probably keep going for a bit more. Alright, so we have the binding power table done. Now comes this part. Parsing expression. So what should we do first? Parse expression, NUD, or LED? Probably parse first. Yeah. Let's just get all these in there. So I'll probably put it down here. I think a lot of people glaze Rust, right? A lot of people do. And I might be one of those people in the future. Who knows? Just putting that out there. What's up, Max? Welcome to the stream. Alright, so parse expression. Let's try and think. So basically we're just going through the expression and we're just basically comparing it against the binding power that is presently there. So if we have like, we have a bunch of literal values, like, I'm gonna use the same example, 1 + 2 × 3. Each of these are individual literal values that we have. These are the operators that we have. And we're basically just checking the precedence of the previous. So in this case, we're taking 1 because probably the binding power they'll pass in is 0. So that's fine. But once we get a plus, the binding power of, I believe I put 40 or 30 on it. That will take in the left node here. Then we check this, but since this has a binding power higher, it should like enter another loop where it handles this. Yeah, I think we can default them into 0 in the function. I think we can. So, kind of having a little bit of trouble thinking of this. Okay, let's think how we even call parse. Let's go back to starting. Calling parse expression, right? We did call parse expression a lot in our statements whenever we hit an expression. So let's just go back to like our if statement or something. The if statement here, it called parse expression once we hit the condition. But we didn't consume the condition token yet, right? So it's gonna pass to parse expression. We are automatically called it 0 here, like you said, Swan. I think Swan said that. Yeah. Yo, this man was crazy. Let's refrain on the spamming for a little bit. Okay, so we are calling, okay, so we're calling expression, right? So, as we said earlier, so we're calling expression. So now we're in this expression function right here. Our default binding power is 0. But we haven't consumed the token yet. Or we haven't basically got that token ready for the first one. So we wanna, but that first token, let's say like it's like, I don't know, I'm gonna do an example maybe. Like I don't know if you have something like x equals y, right? We need to grab this and we're probably gonna use it later. So let's maybe make it into a variable, I guess. And that's gonna be a token itself, right? I believe. So probably like token, we'll say, or token, I guess we'll say token. And we want to advance that value, so essentially we're grabbing that value and then advancing forward. Because we're already at that value. So we want to grab it and return it here and then advance forward by 1. What else? So now we've hit the equality operator. I mean, I guess to take that first token, right? This is where the nud function would come in handy, because that doesn't have anything to the left of it. Let me just read again. Handles prefix tokens, start of expressions. Yeah, so start of expressions, we want to handle it with a nud. Token that has absolutely nothing to its left. It is start of a brand new expression. Nud builds a lead. Yeah, okay. I understand. So we probably want to set like the nud here, which we haven't implemented yet, but we'll probably say like, what is nud gonna take? Nud can take a lot of things. Nud can take a lot of things, right? Like, what is nud? Takes in just one value, right? The token. But we don't know what it's exactly gonna take, so maybe like auto. We can probably call that like the left node, and say call nud on it with the token that we had. you did uni level C for CS, which at least my uni doesn't cover anything embedded. That stuff is getting kept by electrical engineering people. Sounds about right. Make a compiler and assembly next. That'd be something. We're writing a whole compiler in assembly. That's the kind of is very complicated. What's next here? So we have the token. So now, okay, so now we're on this part. Yeah, I'm sure someone did. Like, definitely someone has done that before. I just don't think I'm the one to do that. But now we want to check. So now we need to actually check precedence, right? So but this can be like any amount, right? It can also be like, I don't know, any random thing, like equal, not equal to, z equal. We don't know what the programmer would write, so there's an infinite amount of stuff we can write. Even for expressions, it could keep going on here, like -2, whatever is there. So it's probably going to be a while loop. A while loop here, probably. Maybe. Yeah, me neither, Max. I'm not a masochist, so I'm not gonna be doing that. Making it make files crazy. After this parse expression, we might end the stream. After this function. So essentially we're just walking through, checking if the binding power of the previous, if it's greater than the minimum binding power that we have already. We're essentially just walking down that path to see, walking down the tree. So I guess we can say like, maybe call the binding power, because we need to check the binding power of whatever we have with the min binding power. So binding power, and what are we passing in? The binding power of the token, right? Or, well, no, not the token. The token would be this. We're checking the binding power of this. So I guess peak. Because we don't know, we can't use check because we don't know what we're checking. It could be anything. So I guess peak would get the current value without having anything to check. So peak. Okay, so peak. I'm really slow right now. Okay, binding power of peak. If it's greater than or equal to greater than? Well, I guess greater than, right? Yeah, greater than, probably. So min binding power. What's up, Lego? Welcome back. And you guys are having a whole conversation in there. Okay. binding power, checking the binding power. I actually have 3, but they're not, I'm not even using them right now. I don't have a reason to use them. And one's not even connected, I don't think. Don't forget to like the stream. Yeah, absolutely like the stream. Okay. I'm using my phone, it's just my chat is right here on the phone. Because I mean, I could move it over, but it's, yeah. It's kind of, I could, I guess, but I'm just using my phone. I just have it like mounted up right there. Binding power. Okay, yeah. How many lines of code is your lecture? Well, the CPP is around 200. The header is probably like 150, okay. Yeah, so just around 400-ish. Okay, so the binding power of this, checking the binding power of the just the minimum binding power that we have. As long as it's greater than the minimum binding power. Okay, so we're at the operator right now. The operator. We haven't consumed the operator yet. Or went into the operator yet. So, so you probably want to do another advance to go to the next one. So we have the operator, and we probably want to advance to the Y now. Or, no. That's the wrong way of thinking about it. We want to grab the value of this and then advance to Y. So the value we're grabbing will be token op, the operator. You can't write operator in C++ like that without it doing something, so since that's for overloading. Okay, token op. Yeah, we just want to advance. So that will return. So this one returns our first token, advances over to equal, and this one grabs our equal, and then advances to Y. $61. That's crazy. Or did you just bait me into that one meme? Did you just bait me into saying that one? It's crazy. Okay, so we're advancing. This is where we probably call the lead function, right? Because over here we did the nud function once we advance past the token to assign it a single token value. But now we need the lead function. The left denotation function grabs its left node and also the current operator. Let me just read. So this should handle infix tokens, middle of expressions like plus or that. Obsidian is weird. I don't know why it hides that sometimes because it's indenting. Yeah, and the parser's already parsed a chunk of code on the left and it encounters an operator that wants to connect that left chunk to a new right chunk. Okay, So we probably pass that into the left node itself. So left node. I want to call the function here. So led operator. I believe led takes the operator first. Operate first, and then the unique pointer to the left node. So std move then on that left node that we had earlier. And is that it? Keep streaming until 1? Maybe. Kind of felt of ending it after this function, but I guess we can do another function, maybe like the let or node function, probably. Yeah, I'll see. Depends on how I feel to end it or not. Is Mac OS. Here's Windows 11 extra bloatware. That's crazy. What's up, username? Welcome to the stream. And that's crazy. I didn't even know that meme is still alive to this day. I wouldn't even be surprised if someone made the 6.7 OS. That would actually be not very surprising if someone actually did that. Python and Lua installed. Alright, so now we actually have... Alright, so we have the left token that we have, then we have the binding power that we checked. So we now have x equals. And we do the same thing over and over again until we reach it. So it just essentially keep going on over and over again, no matter how long we go. So for y, it'd go back and do the nut token again, and then so on and so forth, I believe. So I think that's it for that. And we want to return the unique pointer, so I guess just return left node. Oh, it's his alt account? I guess I probably should have seen that. I mean, I guess he's not really doing much, so I guess as long as he's not like going overboard, I guess we can keep him in there. What's up, Soj? This is a subset of C compiler. It's a C compiler compiling a subset of C and then passing that over to the risc-v CPU emulator over here. I'm gonna ban him. I should also try to make a language. Sounds like another fun summer project to add to my already full project plate. What projects are you doing, AJ? Currently? Alright, Ghost. Alright, Ghost. I won't ban him, but I'll time him out for a little bit. Because he does have his other account to use anyways. I accidentally removed it. I'll just time him out for, I don't know, 30 minutes. To be honest, I don't know when to time people out. I don't know, like, when to do all that stuff, to be honest. I guess the only apparent ways to know when to time out someone is they're being, like, rude or something. I think that's it for the parse expression. I've been working on a heads-up clone for iOS because their packs aren't fun, and I wanted to make my own. Also learn iOS app dev. Wanted to sharpen my C skills, so trying to make a heap allocator. That's quite a list of projects that you have. It's pretty interesting. No, I have not heard of TrumpScript Max. Is that like an actual thing? What is it? What does it even do? What's its use case? Number 1? Oh yeah, AJ Brady is number 1. You guys are tied for number 1 actually. Both at 225 XP. It's an esoteric language on GitHub. That's very interesting. Let's see. Nod. I'm probably gonna end it off today, to be honest. Let me just get these function names in, but I'm probably gonna end it off here and probably leave the implementations for these to tomorrow. So tomorrow we'll likely, or maybe day after, I don't know. We'll likely do the nud, the led function. We probably have to set up we have to update our run function. Our run function to actually take in for the parser. We have to make it like that. We also have to do error handling tomorrow too, and I think that would be it. I think that would be the oh yeah, and also the parse code function, which will parse everything. So yeah, let me just set this up real quick and we'll probably finish up. Also wanted to make a Jujutsu native macOS app. I also had an idea for a better way to share trip content, kind of like a scrapbooking app for iOS. Possibly a camera app to learn AV Foundation. Dude, that's a lot for one summer, not gonna lie. That's actually a lot. I wish you the best of luck though for that. The clone for iOS sounds very interesting though. The heads up clone for iOS. Yo, what's up, Brennan? Bro, you can make cheat? What do you mean by that? Like, make video game cheats? Oh, okay. Yeah, make video game cheats. Maybe. I don't know how to do that yet, though. Maybe that's a thing for some other time. How long have you been writing C? Well, this is not C, this is C++, but just for a couple months. I started in mid-March. Before that, I was using Python. You used to make video game cheats, Jennifer? Or like something else? It's on test flight, so I can send you an invite if you want to try it. Yeah, I'm down to try it. I believe you're in the Discord, right? So you can just send me a message. Cheats, video game cheats. Seems interesting, but I just don't know how to do it yet. I mean, there's so much to do in this whole space. Yeah, maybe. I'll probably like be working on this compiler for a long time, but I'll probably take a break after the base compiler's done and then probably work on something else for a bit. Yeah, I answered your question about the how long you've been writing C, right? Well, yeah, this is not C, this is C++, right? So just a couple months back in March. I started in mid-March. And it's like the end of May, so yeah, 2 months. Just about 2 months. C++ or Python? Yeah, I was doing Python before. I am having much more enjoyment with C++. Python was maybe a year. I learned it in uni my first year, last summer. And then I just used it ever since. I used it for OOP class. I learned some data structures on my own on that, but not too good at that. Here's an idea. Once you finish this, you should test compile the GNU stuff because their coding sounds awful. It'd be a good way to see how resilient / adaptable a compiler is. Alright, I'll keep that in mind. But yeah, I think that I will probably be ending the stream now. I appreciate you all for joining. We had AJ Brady, Jennifer, Ghost, Swan, EXO, Soj, Max, Eslo, Brennan, EXO, if I didn't say his name, Lego. We had a bunch of people join the stream today, so yeah, really appreciate you all for joining, and I think I will be ending the stream today. Good night, everyone.